Hello everyone, my name is Ji-Dong Lee, and I am pleased to present our work titled OpenImplicit, Benchmarking Implicit Reasoning in MLLMs via Open-Ended Evaluation, accepted at ICMR 2026. Multimodal large language models have achieved impressive progress on vision language tasks such as visual question answering and multimodal reasoning. However, strong performance on existing benchmarks does not necessarily imply robust high-level reasoning. Most current benchmarks primarily evaluate explicit perception, that is, what is directly visible in an image. But a more demanding and arguably more important capability is understanding what an image implies rather than merely what it depicts. Implicit meaning understanding requires models to infer latent intent, satire, stance, or critique by integrating visual evidence with external knowledge including cultural conventions, historical context, and social norms. This raises our core research question: can MLLMs truly understand what an image implies? Existing benchmarks for implicit understanding such as DeepEval, Insight Vision, Mimica, and CY-Bench all rely exclusively on multiple-choice questions. We argue that this evaluation paradigm is fundamentally insufficient. When the correct answer is exposed among candidate options, models can succeed through process-of-elimination or shortcut heuristics, without engaging in the complex reasoning required for genuine implicit understanding. High accuracy may therefore reflect the ability to guess among options rather than true comprehension. Let me show you a concrete example. Consider this image depicting a person with a water gun disrupting swimmers at the starting line. When we present this as a multiple-choice question, the model correctly selects the answer that the image mocks unprofessional behavior. However, when we ask the same model to explain the implicit meaning in an open-ended format, it generates an incorrect interpretation, confusing the sarcasm about unprofessionalism with a critique of competitive rituals. This gap motivates our work. We need evaluation formats that can distinguish genuine implicit reasoning from option elimination shortcuts. To address this, we introduce OpenImplicit, a benchmark that uniquely combines both multiple-choice and open-ended questions for the same images. This enables a direct, fair comparison between option-guided selection and independent reasoning. We define 3 evaluation tasks: caption, which tests visual content recognition; knowledge, which evaluates whether models possess the bridging external knowledge; and implicit, which includes both MIC and open-ended components. The former asks models to select the correct implicit meaning, while the latter requires them to derive and articulate it independently. Constructing such a benchmark at scale presents significant challenges, especially under limited human annotation budgets. To solve this, we develop an automated MLLM-driven annotation pipeline. The pipeline works in 3 steps. First, we use a teacher MLLM to extract latent semantic attributes from each image, generating 3 ground truth descriptors. Second, we generate 4 distractor options subject to strict constraints: consistency in length and style, plausibility without visual context, relevance to the image, and semantic uniqueness from the correct answer. Third, we augment each image with a subjective open-ended question requiring generative reasoning about the implicit meaning. To mitigate hallucinations and biases from automated annotation, we implement a rigorous 3-stage quality assurance protocol. Stage 1 is multi-model cross-verification, where a high-capacity MLLM filters samples that fail to meet our predefined logical and semantic criteria. Stage 2 is vision dependence verification, a blind text check that discards any samples solvable by a text-only model, ensuring our benchmark genuinely requires visual understanding. Stage 3 is human-in-the-loop auditing. 3 graduate-level annotators independently verify sampled data, achieving acceptance rates of 92.5%, 94.3%, and 90.6%, with a Fleisch kappa of 0.68 indicating substantial inter-annotator agreement. The final dataset contains 6,331 high-quality samples organized into 5 major categories and 17 subcategories. Our dataset covers diverse topics including political ideology and governance, social issues and inequality, environmental and public health, cultural and philosophical reflection, and economic systems. The category distribution reflects a trade-off between topical balance and dataset scale, with political ideology accounting for the largest proportion due to source distribution. Now let me present our key experimental findings. We evaluated 9 representative models including both open source and closed source systems. The most striking finding is the consistent and substantial performance gap between MCQ and open-ended evaluation. When models are asked to generate open-ended explanations for the same images they previously answered correctly via MCQ, their accuracy drops dramatically. For example, Gemini 2.5 Pro achieves 97% on MCQ but only 62% on open-ended questions, a drop of 35 percentage points. Internvel 3.58b drops from 75.9% to 44.9%, a decline of over 31 points. We also observe a clear scaling trend. Smaller models suffer significantly larger degradations, suggesting heavier reliance on option elimination. In contrast, larger models like Qwen 3VL to 3.5b show only a 5.6% drop, indicating stronger intrinsic reasoning ability. These findings empirically demonstrate that MCQ-based evaluation can substantially overestimate implicit reasoning performance, and that open-ended evaluation is necessary for faithful measurement. This slide shows the topic-wise performance analysis across 5 implicit reasoning categories. The main takeaway is that performance is highly category-dependent. Qwen 3VL235b is the strongest overall model and leads on most dimensions, but no single model dominates every category. A notable result is that MIMO VL7b, despite having only 7b parameters, performs comparably to GELM 4.6v and even exceeds Internvel 3.5 to 4.1b on several categories. Kimi VL a 3b achieves the best score on political ideology and governance, while the remaining 8b scale models trail behind the leading systems by a clear margin. Beyond evaluation, we investigate whether implicit reasoning can be actively improved. We propose a 2-stage training recipe: supervised fine-tuning followed by reinforcement learning using GERPO. We curate 4,000 additional training samples, 2,000 for SVT and 2,000 for ARL. The key innovation is our reward design. We use the open-ended implicit answer scoring rubric as the sole reward signal, normalized to the 0 to 1 range. Starting from Qwen 3VL8b instruct as the base model, SVT improves performance by 1.7%. Adding GERPO further boosts performance by a total of 4.4% over the baseline, with MCQ accuracy reaching 78.2% and open-ended accuracy reaching 77.1%. This demonstrates that our open-ended evaluation not only provides more faithful measurement, but also serves as an effective optimization target for improving implicit reasoning. To summarize, our work makes 3 main contributions. First, we propose an automated annotation pipeline with 3-stage quality control that enables scalable benchmark construction under limited human budgets. Second, we introduce OpenImplicit and reveal that existing MCQ-based evaluations substantially overestimate implicit reasoning ability. Open-ended evaluation is necessary for faithful assessment. Third, we demonstrate that reinforcement learning with an implicit reasoning reward signal can significantly improve a model's ability to derive and articulate latent meanings. We believe implicit understanding remains a significant challenge for current MLLMs, and we welcome the community to advance performance on our benchmark. Thank you for your attention. Our dataset and code are publicly available on GitHub. This work was supported by the Ant Group Research Fund. If you have any questions, please feel free to reach out.